So this video is going to go over how you're going to work on your performance task part 2. So you're going to be doing linear regression using Desmos. So we've used Desmos a few times. So here's going to be a sample of how it's going to go. I'm just going to do it with a lot less data, but yours is going to have 25. It's going to be the same idea though. So in this case, I'm going to be showing you guys data based on a first quiz score for 8 students and their second quiz score. We're going to use that data to find something called the line of best fit. I'll get into that a little bit more as we're going over it. We're going to plot these points on Desmos. We're going to put the line of best fit over the data. So we'll have the point and a linear line. And we're going to use that line to make some predictions for future test scores. And more specifically, we're going to be doing 5. So we're going to start off by first going to desmos.com. So general idea is we hit desmos.com. Most of you guys will have it saved already. Hit enter. Start off by launching the calculator. You're going to hit launch calculator. It'll take you into the graph. You'll click on this plus sign to add an item, which means in this case we're going to add our data. We're going to put it on a table. So you're going to start typing in your data, whatever it may be. So for example, like it was 10, I believe, for the first quiz score, and second quiz score for the same student was an 11. Now notice I don't see the point because it's off my grid. So I'm going to go and switch to another tab where the data is already there. Same idea. So once you're done entering your data, all 25 points in your case, I'm just going to zoom out here until I see the data. I'm just clicking on this minus sign. And as I can see, this has a positive correlation because my points are heading upward. So I don't need the second quadrant, the third quadrant, or the fourth quadrant because all I have is positive data. So I'm going to click on this wrench and I'm going to change the grid that I have. So I don't need to go into the negative, so I'm just going to put -5 just to have a little bit of a gap on both the x and the y-axis. So notice my origin is now in the lower left-hand corner. Now I'm going to change my numbers on the other end of the x-axis. So I want to go from -5. I'm going to go to 60 because my data doesn't go past 48. These are already in numerical order for you guys. You don't have to put yours in numerical order if you don't want to. So again, I'm going to do 60 on both the x and the y, because again, they both go close to 50. I'm just going to add a little bit of a gap for them. Then you can click on the wrench and it makes it go away. So again, we can still see this positive correlation. So the idea is we're going to put a line of best fit. This is going to be linear data. All the stuff that you guys collected is linear data. So we're going to draw a line that's going to hit all the points or as close to all the points at once. So generally, you would just kind of estimate it. I'm just going to draw a quick line where I think the line of best fit is at. So it's somewhere approximately right here. Notice that my line is very close to all the points. It either hits them or is very close to them. Now, it's not perfect because I just did this freehand. I might be off by a little bit, but that's kind of what a line of best fit is, the line that fits all the data the best. So I'm going to remove the line now, and we're going to actually do the correct line. The program here will do this for us. So the way we do it is we click on this plus sign to add a expression, hit f of x for our expression. So it's going to actually put it for us. Actually, let's just put it here. Now we're going to put our y equals mx plus b equation. So when I enter my y equals mx plus b, I want it to use the actual data. Notice my x has a subscript of 1 and y also has a subscript of 1. So when I enter y equals mx plus b, I'm going to put those 1s on it. So just type a 1 and it makes it a subscript. Instead of putting equal sign, I'm going to put the tilde sign, the little squiggly line. So hit second, shift. It's on the upper left-hand corner. If the little keyboard pops up on yours, if you want to find it, it's going to be here under click ABC. It's this button right here if you can't find it on your keyboard. You can always X out of this. Then we're going to hit the y equals mx. So m, again, x has to have that subscript. And then I hit notice the line popped up. So it's not quite the line of best fit. I'm going to add the plus, and I'm going to put my b. So there's the actual line of best fit. You can actually click and to see where the y-intercept is at, 0.29. So you can actually click on the line anywhere you want and figure out any point you want. But again, let's go back to our equation. So we have our m. This is my m value. It's actually not clicking where I wanted to click. There it is. That's my m value, my slope, and my y-intercept is right here. So I know my slope and my y-intercept. Again, when we click the y-intercept here, it was just rounded to 0.29 as opposed to 0.28802. I'm going to click that. So again, notice that this line in orange hits all the points fairly close. Again, you can change the color of the line. You can make it go away. The way you do it is just hit the edit button, and you can always click on it, change the color. I can make it purple. Same thing up here. I can hit edit. I can change the color of the points. I can make them red if you prefer, and hit done when you're done with it. So now that we have our line of best fit, the way we know this line is a really good line is by looking at this R value, which is called the correlation coefficient. So this R value here, let's get rid of these. I'm going to highlight the R. This is a correlation coefficient that tells us how good of a line this is, with how linear to the data it is. The closer this number is to 1, the better of a correlation it is. In this case, it's very, very close to 1, so it's a very good correlation here. So now we're going to go ahead and do some predictions. I'm going to retype this equation, but with the equal sign, and instead of actually typing in my M value and my B value using these two right here. So I'm going to go ahead and type in Y. I'm going to put the equal sign. I'm going to copy my M value. I'm going to paste it. I'm going to put my X. I'm going to put my plus sign. And I'm going to copy B. When the line appears, it's going to be on top of the other line. Or should be on top of the other line. Why isn't it on top? Oh, I copied the wrong one, that's why. So let's go ahead and do this one again. I'll just type it by hand. 28802. So again, this new line should be on top of the previous line. You can't see the purple line, now the red one's on top of it. Let's change the color so you guys can see that. Hit edit. Let's change it to green. So these two lines are on top of each other because they're basically the same line. So to make predictions, I'm going to make 5 predictions. So I'm going to go ahead and click on edit. Notice that this table pops up next to the equation we just typed in. I'm going to convert my equation to a table, so click on it. And it just puts it on a table. So my X value is whatever I want to choose. My Y value is the MX plus B that I typed in earlier. Again, we're not going to make negative predictions because that doesn't work with our data. It's all positive. So let's say I want to make 5 predictions. What would be your quiz score for quiz 2 if you got a 20 on the first test? Notice that the Y value automatically changes. So in this case, you'd get a 19 point, let's say 5. Let's say we predict that, what about if I got a 60 on the test? My prediction for quiz 2 would be 57.8. Let's say I predict, what if I didn't do so well, didn't study, I got a 15 on the first test. Prediction is a 14.7 for quiz number 2. Let's make 2 more predictions. Let's say 33. Prediction for quiz 2 is 31.9. And one last one, a prediction for quiz number 1 can be 49. Prediction for quiz 2 is 47.2925 or 47.3. So you can also click on the graph. Let's say I want to see 20. Here's a 20. There's a prediction right there, 19.47. Notice the points showed up that I have typed in on the left here. I can also type in, I can also just click on it and I can see what those predictions are if I want to do it that way. So now on your performance test, what you're going to submit is you're going to submit a screenshot of the table, a screenshot of your linear regression line, a screenshot of 5 predictions. You can make any 5 predictions you want. You're going to type these out in a sentence though afterwards. And you're going to have a screenshot of your actual graph. So you don't have to have any like points labeled, but they're just the individual dots. Make sure you choose an X and Y axis that's appropriate for your data. So just make sure you're conscious of that. Remember, I chose -5 to, actually these got changed a little bit. I think I might have moved the screen, but mine's going from -3 to 60. I can always go back and change this to -5 to that 60 that I originally had. And again, it doesn't really make a huge difference because it was just slightly off. So again, just make sure you choose an appropriate X and Y axis for the given data. And that's pretty much it, so go ahead and get started. Now, actually one more thing I forgot to mention. Those of you who chose the height as your part of your data, the ones that did the shoe size and the height, you are gonna have to do a quick change on some of your data because you won't be able to type in 5.7 on your actual data. Desmos won't read this because this is not like an official single number. This is like a height. So it's better just to convert this into inches. And the fastest way to do that didn't come out. fastest way to do that is just to multiply by 12 on the feet. There are 12 inches in 1 foot, so just go ahead and do a quick conversion. So every 5 feet, in this case, you're gonna multiply by 12. Most people are 5 foot something that you collected data from, so that should be 60. And then you're just gonna add those 7 extra inches. So 67 would be the conversion, so for this case. So 5'7" would be someone who is a total of 67 inches tall. So you would use the 67 in your data table. So when you start working on your table, someone who's 67 inches tall, their shoe size would be like 8.5. When you type it into decimals, make sure you put 8.5, not 8 1/2. It's probably easier to type it that way anyways. So go ahead and get started, and good luck.